In this course, I will give you a quick overview about this course. So what are the things we are going to do in this course? For this course, ST's microcontroller based board is required. Now it doesn't matter which board you have, whether you have STM Nucleo, Discovery or Evaluation, so you should be able to use this. But if you are planning to buy a board, then I would suggest you buy a 4X based or F7X based microcontroller board. And I have also explained about the board in this course. Okay, so if you are total beginner, then you may go through that section. So in the upcoming section, I have explained about the board which I have used in this course. So as I said, so this board is used in this course, the STM32F446RE Nucleo board. Now the IDE of choice is OpenSTM32 System Workbench, and the reason is it supports all the OS platforms such as Windows, Mac and Linux. Okay, alright, so now let's have a quick overview about the classes. Alright, so in the first section of the course, I'll be covering STM32Cube framework and the supported APIs. STM32Cube layer is a hardware abstraction layer given by the ST in order to handle various peripherals of the microcontroller. STM32Cube layer is a collection of various driver files which are required to handle the peripherals of the microcontroller. So we'll understand the STM32Cube framework, the supported APIs, the data structures involved in order to handle the peripherals, the callback implementation, interrupt handling APIs and so many other things. And we'll start with this section. Okay, now after that I will teach you the fundamentals of timers, and then we'll move on to PWM, because PWM is actually part of timers peripheral. Now in timers, we are going to explore the basic timer, the general purpose timer, the input capture unit of the general purpose timer, and also output compare unit of the general purpose timer, and we'll also explore the PWM mode of the general purpose timer. Alright, so we'll also do lots of exercises in order to test our understanding on the target. And after that, we'll move on to CAN peripheral. So many students requested to put this section. So this section is really important, and I will cover this section from scratch. Okay, so I'll first start with CAN protocol, understanding the frame formats of the CAN protocol, understanding a CAN node, how it works with transceiver, and the bus access when multiple devices are involved, and we'll also explore the internals of transceiver by referring to Texas Instruments transceiver chip. And then we'll come to ST, and we will understand the basic extended CAN peripheral of the STM32 microcontroller, where I will teach you the TX path, the RX path, the filtering mechanism, and different modes of the CAN, such as CAN self-testing modes, such as a loopback mode, and also I will teach you CAN normal mode, where we will have two devices in order to communicate over CAN bus. And I will also teach you how to analyze the CAN traffic by using protocol debugging, how to detect the recessive bits, how to detect the dominant bits, how to detect the ACK, etc. I think so this section will give enough knowledge in order to work with CAN peripheral of different microcontrollers, and also troubleshoot the issues. Okay, now once you know all these concepts, you can apply these things to any microcontroller you have. It's not very much bound to ST. For example, let's say CAN filtering. Now CAN filtering is there on all microcontrollers. It doesn't matter whether it is from ST or it is from TI. So the same concept you can leverage to other microcontrollers as well. And also we have lots of code exercises. Now moving on, after that I would cover low power modes of the microcontroller. Now this is very important, because this section will help you to reduce the current consumption of your application. So we will start with exploring various low power feature available in ARM Cortex-MX processor, and then we'll explore sleep, stop and standby mode of the ST's microcontroller. And I will also take current measurement, and we'll compare the current measurement obtained under standby mode, stop mode, with the data sheet given value. Okay, so that will give you how to obtain the data sheet given value by doing experiment on your desk. Okay, and I will also share with you some of the current saving tips and tricks in order to reduce the current consumption when the microcontroller is running. And of course we will understand all these things by doing code exercises. So it is not just theory, so we'll do lots of code exercises to take current measurement. Okay, now after that I will cover RTC. Now RTC is very important, and there is lots of things to learn in RTC peripheral, and it is one of the most important peripheral of the microcontroller, because almost all embedded system product will have it, right? Now RTC has multiple units like calendar unit, alarm unit, wake up unit, and timestamp unit, etc. We'll explore each one of them by doing exercises, and also I will tell you the relationship between RTC and the low power modes of the microcontroller. Okay, so RTC is one of the major peripheral which is used to wake up the microcontroller when the microcontroller is sleeping in standby mode or stop mode. Great. So apart from that, this course has lots of code exercises for you to accomplish, and whenever you are watching video, so if I am doing any exercise, then I would suggest you to just sit back and watch it. Okay, and once the video ends, you can pause the video and you can do that at your computer, and then you can proceed to the next video instead of frequently pausing the video and doing at your computer. So first watch the video, understand the thing, then pause, then do the things at your PC, and then move forward. Okay, and I hope you will enjoy this course, and let me know if you want to say something. I'll see you in the next lecture.